The scaling law has been applied to generative artificial intelligence so far. In fact, the word observation is more appropriate, based on experience that the size of data used for learning and the number of variables in a large language model have a much greater impact on performance improvement than the improvement of the algorithm itself. Rather than a law, using more parts does not suddenly lead to better cars or airplanes. However, generative artificial intelligence is different. The algorithm and structure are almost the same, but you can get better results by simply growing the model. Moreover, not only does performance improve, but new features that never existed before can also become possible. When simple things come together, emergent properties arise, which are phenomena in which difficult and complex things happen. There is very little that a single nerve cell can do. However, tens of trillions of neurons in the brain make emotion, self, and even free will possible. If generative artificial intelligence continues to follow the scaling law, it is expected that intelligence, ego, and even free will that exceed human capabilities will emerge thanks to emergent characteristics. Recently, the hottest issue in the artificial intelligence (AI) industry is the performance improvement limit issue of large language models (LLM). In the process of learning GPT-5, which is a larger language model than GPT-4, the existing language model, performance did not improve as much as expected. Additionally, OpenAI discovered that the improvement in model performance due to pre-training during the development of Orion was not as great as before. To compensate for this, reinforcement learning through inference and human feedback, RLHF, is needed. Google and Anthropic are also suffering from the same problem. Google is said to be seeking measures such as adjusting hyperparameters to compensate for this. Hyperparameters refer to values that the user sets directly when modeling. When using a machine learning model, there are quite a number of values that the user must manually set. All of them are hyperparameters. There is no set optimal value for hyperparameters. Decisions are often made using heuristic methods or rules of thumb. There are also libraries that automatically select hyperparameters, such as Bayesian optimization. The criteria for distinguishing between parameters and hyperparameters are determined depending on whether the user sets them directly. If the user sets it directly, it is a hyperparameter. If it is determined by a model or data, it is a parameter. They declare that the era of upscaling is over and that they will create a model that exceeds the scaling laws. Although the number of GPUs used for AI training continues to increase, the performance problem has become serious in that we are no longer getting the same level of intelligent improvement as in the past. It is still too early to conclude whether LLM performance improvements have reached their limits. However, what is certain is that the scaling law, which states that model performance improves by adding more data and computing infrastructure, appears to have reached its limit. It appears that it is difficult to make significant progress through pre-training alone. Therefore, the importance of post-training and reinforcement learning, including inference, has increased. However, some argue that AI has not yet reached its limits, and that AGI will emerge within 2 to 3 years. Just as the inference model, O1, that appeared this year opened a new dimension, it is predicted that groundbreaking technologies will emerge in the future. law of scaling is that whenever the size is doubled, energy is saved by 25%. It is said that when an animal's body size doubles, its metabolic rate increases by 75%, 3/4, not 100%. This means that every time the size doubles, energy is saved by 25%. The growth, development, and decline of living things and human society are governed by scaling laws. Larger animals live longer, evolve more slowly, and have slower heartbeats. Now, the scaling law, expanding, is beyond biomes to entire ecosystems, cities, and companies. The bigger the city, the faster disease spreads. The faster businesses come and go, and the faster people walk. Beneath all highly complex phenomena lies a common conceptual structure. It is said that cities also follow scaling laws when their size changes. The only difference is that in this case, the index is 0.85 rather than 0.75, 3/4. The company's scaling law index is calculated as 0.9. When a city's population doubles, the amount of infrastructure needed, roads, power lines, gas pipes, gas stations, increases by 85%, not 100%, anywhere in the world. It is said that the so-called economies of scale, in which efficiency increases as the scale increases, is realized. In cities, the 15% law of increasing returns also applies, which states that whenever the population doubles, socioeconomic byproducts such as the number of patents, gross domestic product, GDP, and wages increase by 15% more than the doubling. Everything is connected, whether living things, companies, or cities, so we need to think integratively. When it comes to understanding complex systems, the past method of breaking it into small pieces and analyzing it has limitations. In fact, many problems in modern society are difficult to solve with experts in one field alone, as many factors are complexly intertwined and interacademic research is inevitable. This is especially true for global-scale problems such as environmental pollution, resources and energy, global warming, and poverty.